atom has 2 pi bonds connected to it. The 2 pi bonds are orthogonal to each other. Orthogonal means in perpendicular planes or just perpendicular. The question says for HCN, create a version of the orbital overlap diagram that is actually, and of course by actually I mean literally, three-dimensional in some way to show the 2 pi bonds being orthogonal. Pictured below is a simple example for carbon monoxide. And best 3D representation in the class gets 5 extra credit points. I'm going to actually not do HCN. I'm just going to talk about CO and how I got this picture. CO is carbon monoxide. It has a best Lewis structure that is here. And what you can see is that there's a triple bond. And remember, a triple bond is a sigma plus a pi, which means we have 2 pi bonds. And for 2 pi bonds, what this whole question says is those 2 pi bonds must be literally perpendicular. And so what you can imagine, and I don't know if this will work, is if you're looking at my hands, or I don't know if this is going to work better, like this. Let's see. Oop. So perpendicular, or orthogonal perpendicular planes is going to be one like this and one like this, so that they are 90 degrees to each other, right? You can see 90 degrees to each other. And what I want you to do for this problem is to create something that is perpendicular, which means something that actually comes out of the page. In this picture here, I've actually, well, I'll draw it down here. So I've got my orbital overlap diagram. I've got C. This carbon has 2 electron groups. For 2 electron groups, the hybridization is sp hybridized. Ooh, let me go back to my page, sorry. For 2 electron groups for this carbon, and for the oxygen, by the way, I've actually got sp hybridization. So I will now draw 2 of these. Each of these is sp, and each carbon has 1 electron for it. Actually, this carbon has 2 electrons back there. But in its bond with oxygen, it will have 1. And now let me draw the oxygen. About right there. Oxygen has 2 electron groups around it. In the back side here, it has that pair of electrons. All right. Now, actually this is good practice for the pi bond from the last question. Now there's going to be 1 pi bond above and below, and from the lecture outlines it looks something like this. This is 1 pi bond with 2 pieces. Above and below the 2 atoms. Above and below the 2 atoms that are bonded together. And inside that, there's actually 2 electrons, and some people draw the 2 of them in the top. I like to draw the 2 of them, 1 in the top and 1 in the bottom. One of them is from the oxygen, one of them is from the carbon, so I've color-coded at least that aspect of it. And of course, when we draw electrons, of course, they're moving around very quickly. So this is just a schematic picture or a rough idea that there are 2 electrons in here somewhere. And now it's time for the other double bond. the other pi bond. The other pi bond actually comes up, over, into the oxygen, and then it goes on the other side, up and over as well. And so the simplest way to do this for whatever molecule you have is to take a piece of paper, draw something like this with an electron on it, and have it taped to your page. I know this is crazy, but so tape it to your page so that it actually sticks out of the page and up. And that is something that is truly three-dimensional. And that's what we're looking for. And, well, when you submit your PDF, it would be hard to take a picture of the same thing on the other side. So as long as you've got it on one side, you'll get full credit. But there should be another one on the other side too, since there are two parts to a pi bond. Anyway, I am looking, that is what it means by actually three-dimensional. You have to have something actually sticking out of your page and show that in the picture. What does it say? Oh yeah, does it say this? You'll be submitting a PDF at least for this. Although a video would be fine too if it shows better. Anyway, so that is how to make a three-dimensional pi bond. And you need this because there are two of them. One of them is flat in the page. One of them sticks out. And you can see that they're perpendicular to each other, just like this. Anyway, any questions about that? And of course, the best one gets 5 extra credit points. What do I mean by the best one? I mean the one that looks, well, the one that is truly three-dimensional, that best represents the perpendicularity of it. And so feel free to get creative.